Greeting from India. Today I'll be discussing my paper Text Image Video Summary Generation using Giant Integer Linear Programming. But before we get into my research, let's first discuss why multi-modal summarization is better. Having multi-modal data can help improve the quality of summary than just unimodal data, as multi-modal information can help users gain deeper insight. Including supportive representation of text can reach out to a larger set of people, including those with reading disabilities, those who are less efficient in language, and skilled readers looking to just skim the information. Major contributions of our work include uh, presenting a novel multimodal summarization task, creating an extension of multimodal dataset, and designing a novel giant integer linear programming framework to address this proposed task. The problem definition is titled TIVS. TIVS stands for Text Image Video Summary Generation. It takes as input multiple documents, some images and some videos, and it outputs some extracted sentences, images and videos. In our case, we assume that single video is sufficient for the task. Multiple documents, images and videos are fed into pre-processing, and then we get image set and text set. And these image set and text set are then fed to a giant ILP framework model, and that inputs text summary and top K images. After some cross-processing, we get a final summary. The giant ILP framework has these three different variables: mtxt, mimg, and mc. The diagonal for mtxt and mimg represent whether the sentence I or image I gets selected as an exemplar or not. The non-diagonal element represents whether xi works for xj as its exemplar. Mijc, where C represents cross-modal, represents whether there is a threshold level of correlation between Si and Ig. And the objective function is to maximize the summation of salience of text, salience of image, and multimodal correspondence. We have various constraints like all matrices are binary. There must be exactly k text and k image clusters in representative unimodal space. An entity can either be an exemplar or be part of a single cluster. For an entity to be selected for final sentence image summary pairs, it must be an exemplar in its vector space. For cross-processing, we get as input text summary and top-M images from the giant ILP framework. Now, we generate our image summary and video summary from this. To extract the images, we select the non-keyframe images from these top-M images, and then from the rest of the images present in the initial input, we select those images who have a cosine similarity between alpha and beta. We have a lower bound because we do not want non-relevant images, and there's an upper bound because we do not want redundancy in a final image summary. The intuition for that is images that have similar annotation scores would help users gain more insight. To generate the video summary, we evaluate a visual score and a verbal score. For visual score, we take summation of cosine similarity of keyframes with selected images, and for verbal score, we take cosine similarity of audio speech transcription with text summary. And then we take a weighted average of these two scores, and the video with highest score gets selected to be the video summary. The dataset, we augment the existing dataset that comprises of 25 topics. Each topic contains 20 text documents, 3 to 9 images, 3 to 8 videos, and 3 text summaries. Now we have to we prepared image summaries and video summaries. For that, we had 3 annotators who scored each image and video on a scale of 1 to 5 on basis of similarity. Then we evaluated average annotation scores, and for all the images and videos, we select the image and videos on the basis of AAS score. We prepare 3 baselines that are based on integer linear programming. Baseline 1 takes as input sentence vector, and the central vector is evaluated as average of all sentence vectors. For baseline 2 and 3, we take as input sentence and image vectors, Whereas in baseline 2, the central vector is evaluated as average of all input vectors. In baseline 3, we give equal importance to all modalities and take weighted average of sentence and image vectors. Our model performs better in Rouge 2 and Rouge L than our baselines. And the average precision score that we get is 59% and average recall is 38%. The reason why when we decrease the threshold value of AAS, the precision recall increased because the number of summaries, number of images in the image summary increase with the decrease in AAS threshold value. For video, we first do a random selection of images for 10 different iterations, and that gives us a baseline of 16% accuracy, whereas our proposed model gave 44% accuracy in extracting the most appropriate video. Here's an example summary of a Russian airline which crashed in Sinai Desert in October 2015. And this is the text summary of that. It selects 2 images and 1 video is selected. That's all. Thank you.